In the mystical forest of Vidyavana, there lived a wise and powerful rishi named Saptak. Rishi Saptak discovered an ancient scroll from the temple ruins of Manidvipa. The scroll contained a magical number known as Shatam Saptana, a number made of 100 sevens in a row. That's right, 100 sevens in a row. One day, Rishi Saptak wanted to share the power of this number with 12 sacred animals of Vidyavana. He pondered, if I divide this great magical number among 12 sacred animals, how many sparks of magic will be left over? Can you help Rishi Saptak figure out how many sparks, the remainder, will be left when his enormous number of 100 sevens is divided by 12? This is the puzzle of Shatam Saptanam, the puzzle of 100 sevens. Welcome to the video. This is Bharat Devyan from Zugzwang Academy. How do you solve a problem like this? I shall help you do that. But before we get into the solution, why don't you take a moment, pause the video, go through your productive struggle to actually try and solve this problem. 100 sevens written in a row, 100-digit numbers made entirely of sevens. 7, 7, 7. It keeps going all the way to 7, 7. 100 times. If this huge magical number is divided by 12, what is the remainder? That's a question. So pause, think about it, try to solve it, go through your productive struggle. And if you're able to solve it, fantastic. Leave your comments in the comments section about how you approached it. If not, let's get going with how the solution is achieved. Perfect. Now, in order to find out what this remainder is going to be, let's understand how remainders work in general. So, if I have the number 12 and if I take another number, let's say 24, and I divide it by 12, then the remainder is 0. In other words, 12 equally divides 24 and the remainder is 0. So if a number doesn't equally divide, for example 27, then what would happen is that 24 would get divided, but then there'll be 3 left over, which would be considered the remainder. So when you deal with a very large number and you're trying to find out, what would be the remainder, one of the ways to go about is the rules of divisibility. So what is the rule of divisibility for 12? It's very simple. It's nothing but 3 and 4, because 12 is 3 times 4. So the divisibility rule for 3 and the divisibility rule for 4 would decide the divisibility rule for 12. So in other words, what we want to come across is a number that's less than 77777 and it's divisible by 12. So in that case, we could rewrite this huge number into the number that's divisible by 12 plus the remainder. So how do we go about doing it? So the clue here lies in starting with 4. So the divisibility rule for 4 is very simple. You take the last 2 digits, and if those 2 digits are divisible by 4, then the entire number, doesn't matter how many preceding digits exist for that number, the last 2 digits is all that matters. So the last 2 digits in the Shatam Saptanam is nothing but 77. Now obviously 77 is not a multiple of 4. So what are the numbers that's going to be less than 77 but a divisible number or a multiple of 4? The answer is 76, 72, 68. So, while this huge magical number of 7 sevens, 100 sevens, is not divisible by 12, because obviously it's an odd number and you're trying to divide it by 12, which is an even number, the number 76 or 72 or 68, as in the number that ends with one of these two, as in a number that's 1 less than the Shatam Saptanam, or 5 less, or 9 less than this magical number, is possibly a number that's divisible by 12. Because it's divisible by 4. But just thinking of one divisibility rule of divisibility by 4 allows you 3 possible answers. That's where the other number comes in. What is the divisibility rule for 3? The sum of the digits recursively needs to add up to either 3, 6, or 9. So let's think about the sum of the digits for this magical number. That would be 7 times 100, which is 700. Recursively added, that allows for 7, and therefore that's not divisible by 3. But what about a number that's 1 less than this? So for example, all 7s except for the last digit, which is a 6. In that case, it would be 1 less than 700, which is 699. Recursively added, it's 6 plus 9 plus 9, which is 24. Recursively added, that's 2 plus 4, which is 6. And this is divisible by 3. So there you have it. The number that ends with 76 is divisible both by 3 and 4. And therefore divisible by 12. So in other words, the number that is arrived at by taking the magical number, the Shatam Saptanam, and reducing just 1 from it. So it's like 99 sevens followed by a 6 is actually divisible by 12, which means the magical number in hand, which is the 100 sevens, is going to have a remainder of 1 if you were to divide it by 12. I hope you found this video interesting and enlightening. If so, please do share, like, and subscribe without fail, and I'll see you in the next magical mathematical puzzle. Thank you so much.